This is geometry for Unit 7. This is Section 7.2. This is page 444. This is from Day 3 homework. We're talking about the converse of the Pythagorean theorem. This first question that we're going to look at is number 16. And with number 16, we're trying to figure out, do these side lengths make a triangle? 10, 15, and 5 root 13. And if they do make a triangle, then what type of triangle does it make? So the first thing I'm going to look at is that we're going to test to see if it's a triangle. So the two smaller sides have to add up to be bigger than the longest side. So we add up to 25. A calculator can be helpful to know that 5 square root 13 is approximately 18.02. So 25 is bigger than 18.02. So in other words, A plus B is bigger than the longest side. So yes, a triangle. So then we'll come over here and see what type of triangle it is. So c squared, and we're going to compare that with a squared plus b squared. So my longest side, which is 5 square root 13, and we're going to compare that with the smallest side and the middle size. So when you square the longest side, we square the 5, and we square the square root. That means you get what's inside. Square 100, square 15. Now 25 times 13 is 325. And as we look here, we're also going to get 325. So they equal each other. So we have a right triangle. The second question that we're looking at is number 17. And its side lengths are 24, 30, and 6 square root 43. Well, first we got to test to see if it's a triangle. So we take the two smaller sides and we figure out their length. We take our 6 square root 43, since that's a funny number. We can plug that into our calculator to see that's about 39.3. So yes, we see that the A plus the B is greater than the longest. So yes, a triangle. So now we're going to test to see what type of triangle that is. So we're going to take our c squared and compare that to a squared and b squared. 6 square root of 43 squared is compared to 24 squared and 30 squared. Well, when you square something like this, you square the 6. You square square root, you get what's inside. 576 when you square 24, and 900 when you square 300, or 330. 36 times 43 comes out to be 1,548. And when we add these two together, we get 1,476. So c squared is bigger. You want to write your triangle in this order of c squared going first, because that helps you identify if c squared is larger. Larger means bigger, and that means it's going to be an obtuse triangle. If you mistakenly set this up in a different order, and put your AB first and then your C, it'll look like AB is less than your C squared. And if you say less than, you don't typically think bigger. So you want to have your C go first. Number 18. We got 5, 6, and 7. So we see that 5 and 6 equals 11. And of course 7 is the other one. So the A plus the B is obviously greater than the longest. So now we're going to test to see what type of triangle that makes. So 7 squared compared to 5 squared and 6 squared. 49, 25, and 36. 49 is less than 61. So if it's less than, then we know it's acute. So over here, don't forget that 5 plus 6 equals 11. That is going to be a triangle. With 21, that's the length 15, 20, and 36. So I can test that out as 15 plus 20, which equals 35. This time the two smaller sides are not bigger than the longest. So we have that A plus B is less than the longest. So that doesn't even make a triangle. So there's no need for us to continue to figure out what type of triangle it is, because that's not even a triangle. Number 29. The side lengths that we're going to have for number 29 are 5x, 12x, and 13x. We have to decide what type of triangle that is. Well, one real quick answer is that we look at this and we know we might recognize the Pythagorean triple. 5, 12, 13. Another way to look at this is to say if you take 13x and square it and compare that to 5x and square it, got to put the square on the correct side of the parenthesis. And 12x and square it. You got to use parentheses for that because you want to square the 13 and the x. You want to square the 5 and the x. You want to square the 12 and the x. So 169x squared is going to equal 169x squared. So we have a right triangle. That's because c squared equaled a squared plus b squared. On the second side, just a couple more questions. We're looking at number 35. We have a frame, and the frame is 10 on one side, let's say 10 on one side and 8 on the other. And the question is this frame have 90-degree corners? Is there a way we can tell with a ruler? Okay, so what we'd suggest, again, we have to figure out what this third side of this triangle would be. So one way to think about that is to say c squared, 8 squared and 10 squared. C squared, 64 plus 100. 164. C has to be the square root of 164 inches. So if that's 164 inches, if we were using a ruler to help us identify that, we could take the square root of 164 inches. So that's going to be approximately 12.81, a little bit over 3/4, 12 3/4 inches. So that would be a way that you could test it to see if that is going to be truly a right triangle, making the sides perpendicular to each other, making your frame 90 degrees in the corner. On the last question, number 36, we're going to walk 749 feet from home to the gym. Then from the gym, you're going to walk 800 feet to the library. So the question is, could we be, if we walked 800 feet, could we be exactly, is home exactly north of the library? If it's exactly north of the library, then we need a 90-degree angle. To get home, that's 305 feet. So we're just testing to see if this makes a right triangle. So we're going to take our longest side, square it, take our shortest side and our medium side. Calculator could be a little helpful here. 64 and our 4 zeros. 305 squared is 93,025, and 749 squared gives you 561,001. So we're trying to test to see what that's going to give us. 640,000. And when we take our number and add 93,025 to it, we get 65,426. So that is larger. C squared was less than. So this is really an acute triangle. So it's actually short. This has got to be an acute angle. It would not be 90. It would not be greater than 90. So the way I've drawn it a little wider, but it would be short of 90 degrees. So the best way I could have drawn it would be to come in here and make that my library, and 305 was that length. So that's more about what it would be.